Alright, so try to finish up the prereq section 6 on factoring examples. This one, when we're trying to factor this, why don't we try factoring by grouping? Let's see how factoring by grouping goes. So I'm going to group the first two and I'm going to group the last two together. So when I group this, I have the 16s. I'm going to take a 16 out of both those, and they also have two x's that I can take out of each. So when I do that, I have a 1 left over inside, and I have 1x left. Negative 48 divided by 16 is a negative 3, and both those x's are gone. Now, what can I take out of both of these that would also make it look like x minus 3? That's the real question. Well, I could take a negative 1 out of both those, because if I do take a negative 1 out of both, I'll be left with the x minus 3. So, since those two terms are the same, I know that I was able to factor that correctly. So I take the first two items, push them together, you get 16x squared minus 1, and I drop that down to give you an x minus 3. Now, first step was great, except is this the difference of squares? Remember, minus signs, you have to take a look. Can you rewrite 16 as something squared? Yep, you can rewrite that as 4 squared. Can you rewrite 1 as something squared? Yep, you can rewrite that as 1 squared. So the point is, this is a difference of square. That together is a 4x, and that is a 1. So I can actually rewrite this as 4x minus 1 and 4x plus 1, and I can drop down the x minus 3, and there is that completely factored. With this one, try factoring by grouping again. So I'm going to take a 2 out of each of those. And I realize that they also have an x squared in each of them. They have two x's there, so I'm going to take that out of both. So when I do that, I'm left over with 1x and a negative 6. Here, when I look at this, is there anything else I can take out? Well, I can take a negative 5 out of both those. And when I do that, I have an x left over, and 30 divided by negative 5 is negative 6. I know I factored by grouping correctly because both these two terms are exactly the same. So, to finish my factoring by grouping, I take the two terms that start it and I put them together, and I drop down that last term, and there it is. Now I look, subtraction sign, is this a difference of squares? Nope. And you want to know why? Can you think of two numbers that'll give you 5 that are exactly the same? Nope. You think of two numbers that are exactly the same that will give you a 2? Nope. So we are done. Alright, looking at this problem, this one's a little trickier, harder to see, but what I want you to realize is this. We're going to use some U substitution to solve these kind of factoring problems, and this is how we're going to do it. This is actually a quadratic. I know it doesn't look like it, but even though this is x to the fourth and this is x squared, it still is a quadratic equation, and here's how we go about solving that. This is x to the fourth. I'm going to rewrite that as x squared squared. And that is an x squared. The reason why I did that is I'm going to use substitution. U substitution to plug a u in wherever there's an x squared, because now that looks like a quadratic. Everywhere where there is an x squared, I put a u in its spot. See that? So now you can factor that. Now you can factor, because now what multiplies to give you negative 24 that adds to give you 5? Well, that happens to be 8 and negative 3. Because 8 times negative 3 is negative 24. 8 plus negative 3 is positive 5. So when you're doing this, you actually end up with u plus 8 and u minus 3. Well, this is if we were solving for u, but we aren't. We're solving for x. So now I take this x squared and I plug it right back in for u to get my two factors. The key here is if you see something that is an x to the fourth, most times you do want to rewrite it as x squared squared, and hopefully that's enough to give you a hint that whenever you have an x to the fourth, you normally do want to rewrite it as an x squared squared, that this would be a u substitution type of problem. So in this one, we'll factor this one. I notice that I can rewrite this as x squared squared, because remember it's x to the fourth, and because it's an x squared and an x squared, that should be signs that we're going to do u substitution. So I can rewrite this as 2u squared plus 16u plus 24. So I can take a 2 out of everything to give me u squared plus 8u plus 12. And can you think of two numbers that multiply to give you 12 that add to give you 8? I can, right? 2 and 6. Because 2 times 6 is 12, and 2 plus 6 is 8. So I have that 2 still on the outside, and I can rewrite this as u plus 2 and u plus 6. Except, once again, I have everything in terms of x, not u. So I have to take that x squared and plug it right back in there. So I end up with 2 times x squared plus 2 and x squared plus 6. Those last two u substitution problems, we didn't have any in the notes. That's the first time that we saw those. Those are difficult and they are challenging, I'm not going to lie. But you will catch on with those because we will see a ton of them. So please make sure you understand how to do those, or if you have any questions or concerns, please take the time to email me.